The Army needs these tires by the weekend, gentlemen.
We're running the vulcanizer at maximum capacity.
The viscosity is still too high.
Try increasing the sulfur concentration by 0.5%.
These tires are completely shot. We're stuck here.
I know. It's the same story everywhere.
January 1942. A bitter, cold morning in Akron, Ohio. The hum of machinery fills the air as engineers and chemists move with purpose through the labyrinth of Firestone's sprawling tire factory. The world is on the brink of war, and the United States is still reeling from the attack on Pearl Harbor just weeks before. The global conflict has unleashed a wave of demand for military vehicles, tanks, and aircraft. But one of the most vital materials for the war effort is in short supply: rubber. The Japanese control the supply lines, cutting off access to Southeast Asia, the world's primary source of natural rubber. America's war machine begins to grind to a halt, not from bombs or bullets, but from the rubber that keeps the wheels turning. Inside Firestone's research labs, a team of scientists is on the edge of a breakthrough, one that could alter the course of the war. The task is clear: find a way to produce synthetic rubber, and do it fast. But the pressure is immense. The fate of the nation's military mobility rests in their hands. The year 1942 was a pivotal moment in the Second World War. With the U.S. now fully engaged after the attack on Pearl Harbor, its military production was at full throttle. Tanks, trucks, and jeeps were needed in vast numbers, while aircraft flew daily missions over hostile territories. But there was a problem that, though less obvious, threatened to undermine everything. Rubber, a material essential to almost all of these machines, was in short supply. The Japanese occupation of Southeast Asia, which controlled the vast majority of the world's rubber production, had severed America's access to the raw material. Without rubber, the vehicles essential to modern warfare, planes, trucks, jeeps, and tanks, could not function. Rubber was everywhere, from the tires on military trucks to the boots soldiers wore in the field, and even to the gaskets in crucial engines. The United States, already fighting a war on multiple fronts, could not afford such a vital commodity to be restricted. The critical shortage soon escalated into a full-blown crisis for the nation's wartime economy. By the winter of 1942, American military authorities had already warned that the nation was facing a catastrophic shortage of rubber. Not only was the supply chain completely cut off, but the existing stockpiles were dwindling quickly. For all its industrial might, the U.S. was severely vulnerable to this critical gap in materials. In response, the federal government took immediate steps to address the shortage. The War Production Board, WPB, took charge of allocating resources, but it became clear that without an alternative to natural rubber, the production of military vehicles would come to a halt. To solve the problem, the U.S. had to look inward, and more specifically, to its own industry leaders. The call went out for a solution that could replace the missing material. The answer came from a company that had already established itself as one of America's most important tire manufacturers, Firestone Tire and Rubber Company. As Firestone had already produced synthetic rubber in small quantities before the war, its laboratories and engineers were well positioned to tackle this pressing challenge. The company's leadership knew that the task was monumental. Not only was the technology to produce large-scale synthetic rubber still in its infancy, but they were also racing against the clock. Every day that passed without an adequate substitute meant that the military could not move its troops or machinery. It was a race against time, one that demanded a perfect blend of innovation, determination, and urgency. The stakes were high. Firestone, alongside the U.S. government, needed to develop a synthetic rubber that could match the properties of natural rubber: durability, flexibility, and most importantly, the ability to withstand extreme conditions. If Firestone failed, the war effort could stall. But if they succeeded, they would not only save America's military capabilities, they would also cement their place in history as the saviors of the war effort. As the war effort intensified, the U.S. government began to take decisive action. In 1941, even before the full impact of the rubber shortage was felt, the United States began ramping up its research into synthetic rubber. The Office of Rubber Reserve was established, and a large portion of the budget was devoted to finding alternatives to natural rubber. But this was not going to be an easy task. Natural rubber was derived from latex trees, primarily found in Southeast Asia. But synthetic rubber, which had been in development since the 1920s, was still a relatively young and unrefined technology. The Germans had been the pioneers of synthetic rubber production, using coal and oil to create a version that was more resistant to the harsher climates of Eastern Europe. But despite their progress, it was still a technology under development, lacking the widespread industrial production capacity needed for a full-scale war effort. The United States had its own research and development in the field, but up until that point, it had been limited to small batches of the material, used only in niche applications. The industrial process for producing synthetic rubber on a scale large enough to replace natural rubber was not yet fully established. The Firestone Tire and Rubber Company, however, had the advantage of experience. Firestone had been experimenting with synthetic rubber since the 1930s, testing various formulations and processes. By 1941, they had already produced small quantities of synthetic rubber called BWWII, which was based on a combination of butadiene and styrene. This material had good flexibility and strength, but it lacked the wear resistance and durability of natural rubber. It was far from ideal, but in a desperate situation, it was a starting point. In collaboration with the U.S. government, Firestone scaled up its efforts. The company set up one of the most ambitious industrial research projects in American history. To tackle the problem, Firestone needed not just a synthetic rubber, but one that could be mass-produced quickly to meet the military's needs. Their research team, led by some of the brightest minds in the field, began working around the clock. They had the knowledge, but now it was a race to find the right mixture and the right process to bring it to scale. The urgency of the task was underscored by a chilling realization. If Firestone and the other companies involved in the effort, like Goodyear and Standard Oil, could not deliver, the war effort could be severely compromised. The lack of rubber threatened to halt the production of everything from jeeps to tanks, and even fighter planes. This would have been a blow not just to the U.S. military, but to the Allied forces as a whole. While Germany had its own synthetic rubber industry, the U.S. needed to outpace them in production, lest it fall behind in the arms race. At the same time, the stakes for Firestone were enormous. The company was already a prominent player in the rubber industry, but if it could deliver a synthetic solution on a scale sufficient to fuel the war effort, Firestone would not only secure its future as a dominant force in the rubber industry, but it would also gain the gratitude of a nation at war. It was a chance to prove its worth in the crucible of history, and the pressure was mounting. With the weight of the war effort on their shoulders, the engineers at Firestone worked tirelessly, refining their processes, analyzing the results of each new batch of synthetic rubber, and constantly striving for the perfect blend. But time was running out. The military's demands for rubber were increasing, and the shortage of natural rubber was becoming a full-blown crisis. Behind the walls of Firestone's laboratories and factories, the race to create synthetic rubber was not just a matter of science. It was a fight for survival, not only for the war effort but for the livelihoods of the workers who had been thrust into this high-stakes challenge. The pressure was immense. These were not just researchers and chemists. They were ordinary men and women who knew that the success of their work could mean the difference between victory and defeat for their country. Day and night, these engineers and factory workers faced long shifts, often working 12-hour days, 6 or 7 days a week. It was a grueling, exhausting process of trial and error. Each new batch of synthetic rubber brought with it hope and despair in equal measure. When they succeeded, it was a moment of euphoria, but the fleeting joy was always tempered by the understanding that they were racing against time. Each failure only increased the weight on their shoulders, but it also sharpened their resolve. They knew they had a duty to perform, one that went beyond personal ambition or corporate success. It was about serving their country in its darkest hour. Some workers had lost loved ones at Pearl Harbor, and they channeled that grief into their work, determined to contribute to the war effort in any way they could. Every time they heard the whir of machines coming to life or felt the chemicals react under their hands, they knew they were closer to victory. But victory didn't come easily. With the pressure mounting and the demands of war growing more intense by the day, it was a determination of these workers, who often worked without the recognition they deserved, that ultimately led to the breakthroughs. They understood the stakes in a way that only those living through the war could. The fact that they succeeded is a testament not just to their technical knowledge, but to their unwavering spirit and sense of purpose. The creation of synthetic rubber was not simply a matter of replacing one material with another. It was a scientific and technological challenge of unprecedented scale. The synthetic rubber that Firestone developed needed to match the properties of natural rubber in order to be viable for the war effort. This meant the new material had to have exceptional durability, the ability to withstand extreme temperatures, and maintain its strength under stress. For rubber to function as a tire, it had to provide the right balance of grip and elasticity. These were no small feats to accomplish. Firestone scientists began by focusing on Bunerin, a synthetic rubber that had already shown some promise. The challenge was to refine it, making it strong enough to meet military standards. The material needed to be stable under the punishing conditions that military vehicles endured: high heat, freezing cold, and long hours of wear on rugged terrains. But just as importantly, Firestone had to scale up production. What had been a laboratory experiment now needed to be a mass-produced solution. Every step had to be calculated carefully, as the risk of failure was too great. A single bad batch of synthetic rubber could set back production for weeks, if not months. In the process, Firestone not only developed better methods for synthesizing rubber, but also created new technologies for refining and processing raw materials. They experimented with various combinations of chemicals and new production techniques that allowed them to increase the volume of synthetic rubber while maintaining its quality. This technological ingenuity was a key factor in Firestone's success, and it would go on to influence industries far beyond the war effort. The methods developed at Firestone laid the foundation for what would later become a thriving synthetic rubber industry in the post-war world. The success of Firestone's synthetic rubber project didn't just hinge on the technical aspects. It was also a matter of leadership. Firestone's president, Harvey Firestone Jr., understood the gravity of the situation. As the company's leader, he was under immense pressure to deliver results. Not only did he have the war effort to consider, but his company's future was also on the line. His leadership would determine whether Firestone would remain a key player in the rubber industry, or whether it would be eclipsed by its competitors. Firestone's leadership set the tone for the entire operation. The company's management adopted a collaborative approach, working closely with the U.S. government and other major industrial players like Goodyear and Standard Oil to pool resources and share research. The spirit of cooperation was a stark contrast to the competition and secrecy that often characterized wartime production efforts. Together, they formed a united front to tackle one of the most critical challenges of the war. Firestone's ability to pivot quickly, both in terms of manufacturing and research, reflected the strength of its leadership. Harvey Firestone Jr. understood that his company was not just producing tires or rubber, but rather contributing to the survival of the Allied war effort. He fostered a culture of urgency and perseverance, setting the tone for every worker in the factory, from the engineers to the factory floor laborers. While the United States scrambled to develop synthetic rubber, the Axis powers, particularly Nazi Germany, had already established a formidable synthetic rubber industry. The Germans had pioneered the use of synthetic rubber derived from coal and oil, known as Buna, distinct from the Bunarin developed by the Allies. In fact, by the late 1930s, Germany had already implemented large-scale production of synthetic rubber, giving it a strategic edge in its own war efforts. The Germans understood the crucial role that rubber played in modern warfare. They had invested heavily in synthetic rubber production, especially after the blockade of raw rubber supplies following the British conquest of the Dutch East Indies and the spread of war across Europe. The German synthetic rubber industry was primarily based in the city of Luna, where plants operated at full capacity, producing the essential material for everything from tires to gas masks. Their innovation, however, came with its own limitations. While their synthetic rubber was effective, it lacked the flexibility and resilience of natural rubber, particularly in the demanding conditions faced by military vehicles and aircraft. This was a landscape that Firestone and the other American companies were up against. The Germans had already achieved a certain level of self-sufficiency in synthetic rubber production, while the United States found itself playing catch-up. The race to develop a viable alternative for the war effort was as much about beating the Axis powers at their own game as it was about solving an internal shortage. The competitive pressure was immense, and failure to develop synthetic rubber would not only cripple American industry, but also leave the Allies dependent on Axis innovations, further emboldening their enemies. The war economy's impact on civilian life was immense, and the quest for synthetic rubber was part of a broader effort that transformed the American industrial landscape. For the American people, the rubber shortage was not just a military problem, it was a civilian one as well. Tires for civilian cars became scarce, rationed, and often unavailable. Rubber shortages affected everything from shoe soles to medical supplies, even impacting everyday items like erasers and waterproof clothing. In some ways, the shortage of rubber in the U.S. mirrored the shortages that ordinary civilians were facing across Europe and Asia. Food, clothing, and other essential materials were becoming increasingly difficult to obtain. But in the U.S., it was the tire shortage that became a symbolic marker of the country's involvement in the war. Tires were essential for civilian transportation, but they also represented a crucial component of America's military readiness. The rationing of rubber was a reminder to citizens that they were all part of the same war effort. Communities were encouraged to contribute, and scrap rubber was collected nationwide in an effort to support the production of military supplies. Civilian rationing, along with the tire shortages, was an immediate, tangible impact of the war that helped unify the country behind the cause. It was a reminder that the effort to secure synthetic rubber was not just a technological feat, it was an effort to maintain the war economy, keep soldiers on the move, and preserve civilian life during times of hardship. The creation of the synthetic rubber program, the government-led initiative that oversaw the development of a domestic synthetic rubber industry, was one of the most strategic moves the U.S. could make in the early years of World War II. The War Production Board, WPB, understood that securing a reliable source of rubber was not just important, it was essential for the functioning of the military and the U.S. economy. If the U.S. was to be successful in the war, it needed to ensure that it could produce everything required on its own soil. This vision of self-sufficiency led to the formation of the Rubber Reserve Corporation and its collaborative efforts with the private sector, specifically with companies like Firestone, Goodyear, and Standard Oil. These companies were tasked with ramping up their synthetic rubber production as part of a national effort. The government provided funding, research grants, and resources to these private companies, encouraging them to innovate and push the boundaries of chemical engineering. This public-private collaboration proved invaluable. The industrial scale of U.S. manufacturing was unprecedented, and once the techniques for mass-producing synthetic rubber were perfected, it set off a chain reaction of industrial innovation. Factories like Firestone's became critical nodes in this massive web of wartime production, and soon the country's ability to produce synthetic rubber grew from a desperate experiment into a reliable, industrial-scale solution. Firestone, with its experience and investment in research, was in a prime position to contribute. Yet, the scale at which they were expected to perform was enormous. The factories that had once produced tires for civilians were now tasked with churning out millions of pounds of synthetic rubber each month. It was a monumental shift in American industrial capacity, and it would shape the future of both the rubber industry and the country's wartime manufacturing output. The pivotal moment came in the summer of 1942. By now, the pressure on the U.S. industrial machine was unbearable. The military was rapidly increasing its demands for vehicles, weapons, and equipment, all of which required rubber. Firestone, Goodyear, and other manufacturers were under the gun to scale up their production, but the results of their experiments were still uncertain. The stakes couldn't have been higher. America's entire war machine depended on their success. Firestone's engineers were working under a tight deadline. In June 1942, after months of research, they were finally able to create a stable batch of synthetic rubber that could endure the demands of military vehicles. The breakthrough came when Firestone succeeded in refining butadiene to a point where it could be used effectively in military tires. The team was elated, but the journey didn't end there. Now, the challenge was scaling up production while maintaining quality. The synthetic rubber had to be produced in vast quantities, fast enough to supply an entire army's worth of vehicles, planes, and machinery. This would require not just ingenuity, but a monumental effort across the entire U.S. industrial sector. This was the turning point. Firestone's breakthrough would not only change the trajectory of the war, but also prove to the world that the U.S. was capable of overcoming even the most daunting of shortages. The world watched as Firestone's laboratories went from being a place of uncertainty to a symbol of American industrial might. In parallel, the government had recognized that this moment was crucial not just for the war but for the future of American industry. In the same month, the Rubber Reserve Corporation began working in earnest to ensure that the nation's synthetic rubber supply would be sustainable for the long haul. The massive scale-up began in earnest, and with it, the groundwork for a new era of manufacturing innovation. At this moment, as rubber started flowing from Firestone's plants, it was as though the entire war effort had found new life. Tire production surged, and by the fall of 1942, synthetic rubber began to make up a larger share of the rubber used in military production. Military vehicles and planes that were once grounded or delayed due to the rubber shortage could now be delivered, helping to turn the tide of the war in favor of the Allies. The race was over. Firestone had won. However, this victory was not without its challenges. The sudden shift to synthetic rubber was not seamless. Many of the initial batches still showed weaknesses when tested under field conditions. The tire failures were not uncommon, particularly when rubber was used in high-stress conditions on tanks or aircraft. The stakes were now even higher. A single failure of a tire in the field could mean a destroyed vehicle or worse, the death of soldiers. This created a sense of urgency as engineers at Firestone pushed for continuous improvements. By late 1942, the quality of synthetic rubber was steadily improving, but there were still obstacles. The men and women working tirelessly on the factory floors, however, would not relent. Their work was not just about technology. It was about the survival of their country, and they knew it. The very future of the war effort rested on their shoulders. The turning point of Firestone's success came with the realization that synthetic rubber production could be expanded beyond just military needs. The technology was scalable, and as the war moved into its later stages, the United States began to secure its position as the leading producer of synthetic rubber, not only for military use but also for peacetime applications. The breakthrough not only filled the immediate gap left by the rubber shortage, but reshaped the future of the global rubber industry. By the end of 1942, Firestone's efforts had reached a critical mass. The shift from small-scale, experimental batches to large-scale, mass production had proven to be not only possible but essential for the war effort. The US was no longer merely coping with a rubber shortage, it was overcoming it, with Firestone at the forefront of the synthetic revolution. The development of synthetic rubber was no longer a hopeful experiment. It had become a proven solution to one of the war's most pressing logistical problems. As the Allies pushed back on the European front and expanded operations in the Pacific, the ability to produce rubber at home meant that American forces could stay mobile, powered by vehicles that rolled steadily across distant battlefields. The tireless work of engineers, factory workers, and leadership at Firestone became a critical factor in the Allies' ability to respond to German and Japanese threats. Tanks rumbled across North Africa, jeeps sped across the deserts of Italy, and bombers took off from airstrips in the Pacific, all of them now equipped with tires made from synthetic rubber. This was the moment when Firestone's success transcended the laboratory and found its place in the heart of global warfare. The turning point, however, was not just about the physical rubber that made the wheels of war turn. It was about the national morale and resolve. The United States had faced a crippling shortage in the early days of the war. But as Firestone and its competitors began delivering vast quantities of synthetic rubber, it gave the nation a sense of hope. This was not just about producing tires for tanks. It was about demonstrating the ability to adapt, innovate, and overcome. It was a message that the U.S. could face any obstacle in its path, no matter how insurmountable it seemed. But despite the massive scale-up of production, the challenges didn't disappear overnight. The pressure on the industrial sector was immense, and quality control remained a concern. Engineers at Firestone, alongside their government partners, had to continue refining their processes, working day and night to ensure that every batch of synthetic rubber met the stringent requirements of wartime vehicles. As synthetic rubber began to find its place in military applications, its use began to spread to civilian industries as well. The government, recognizing the vital importance of synthetic rubber to both the war effort and the post-war economy, made lasting investments in infrastructure to support the burgeoning synthetic rubber industry. Large-scale facilities were built, and the country's manufacturing infrastructure was retooled to produce rubber on a scale never seen before. What had once been a niche chemical compound was now an industrial staple, shaping the future of the global rubber industry for decades to come. By the winter of 1943, the U.S. was no longer at a disadvantage in the race for resources. With synthetic rubber production booming, the American war effort gained an unmatched mobility advantage, and Firestone's innovation became one of the key reasons the Allies were able to sustain momentum on multiple fronts. The ability to keep military vehicles, aircraft, and tanks running across the harshest conditions ensured that American forces would continue their offensive, eventually leading to the defeat of both Nazi Germany and Imperial Japan. The aftermath of Firestone's breakthrough in synthetic rubber production reshaped the course of World War II and had lasting effects on both the U.S. and the global rubber industry. By 1944, the United States was no longer dependent on natural rubber imports, and Firestone's contributions were evident in the seamless flow of military supplies. The synthetic rubber program had been a success, with more than 50% of the rubber used by the military now being synthetic. The change in production capacity was nothing short of monumental. In the years following the breakthrough, the rubber shortage that had so severely crippled military logistics in 1942 was nothing more than a distant memory. Firestone and its competitors, including Goodyear and Standard Oil, increased their production exponentially, building new facilities and refining their processes. The tire industry alone was forever transformed, as synthetic rubber was no longer just a wartime necessity, but a permanent part of the commercial market as well. The immediate consequence was a rapid improvement in the mobility of Allied forces, particularly in the European and Pacific theaters. The ability to produce enough rubber for military vehicles allowed the U.S. Army and its allies to keep up their offensive momentum. In the harsh environments of North Africa and the Pacific, where extreme temperatures and rough terrains had once worn down tires quickly, synthetic rubber proved resilient. For the Allies, This technological advancement ensured that they could move men and materials as the war advanced, making it one of the crucial factors in the eventual defeat of the Axis powers. Yet the impact extended beyond the battlefield. Firestone's success in developing synthetic rubber altered the post-war landscape of industrial production. With the war's end in sight, the U.S. found itself with a mature domestic synthetic rubber industry that could power both the civilian and military sectors for years to come. The infrastructure established to produce synthetic rubber during the war was repurposed to meet the needs of the rapidly growing consumer market. Firestone, Goodyear, and others transitioned to manufacturing civilian tires, contributing to the post-war economic boom. For Firestone itself, the breakthrough was both a commercial and a historical victory. The company had proved not only its industrial prowess but also its resilience in the face of an unprecedented challenge. As a result, Firestone became one of the largest and most influential companies in the world post-war. Its role in the war effort forever etched into the fabric of American history. The company's ability to scale its synthetic rubber production to wartime levels gave it a competitive edge, ensuring that its products would be in demand for decades. But the creation of synthetic rubber also had more profound implications. The lesson that could be drawn from the synthetic rubber effort was that innovation in times of crisis often leads to breakthroughs that change the world. Firestone's engineers had not just solved a wartime logistical problem. They had laid the foundation for an entire industry. What started as a desperate scramble to replace a vital commodity turned into a global industrial revolution that extended far beyond the war. However, despite the success of the synthetic rubber program, challenges remained. Post-war, the global market for rubber was once again driven by the natural rubber industry, particularly in Southeast Asia, where the rubber plantations of countries like Malaysia and Thailand became the backbone of global supply chains. The U.S., having developed its own synthetic capacity, was no longer at risk of being left vulnerable to foreign monopolies. But it would also face competition as other nations began to adopt synthetic rubber production technologies. For the Allies, the impact of synthetic rubber production was more than just strategic. It was a psychological victory. It showed that they could adapt, overcome, and innovate even in the direst of circumstances. This mindset would continue to shape the post-war world as nations transitioned from wartime economies to peacetime prosperity. As the war ended, the story of synthetic rubber shifted from a tale of wartime necessity to one of industrial triumph and global transformation. The tireless efforts of companies like Firestone, alongside the U.S. government's support, had not only solved the immediate crisis but had established the foundation for an entirely new sector of manufacturing. In the post-war years, the vast infrastructure built to produce synthetic rubber during the conflict was repurposed to support the civilian economy. This enabled the U.S. to become a world leader in the production of synthetic materials, while simultaneously contributing to the global economic recovery after the devastation of World War II. One of the most visible results of the synthetic rubber breakthrough was the boom in civilian automotive production. The American car industry, which had been severely limited by material shortages during the war, found itself thriving in the post-war period. The ability to produce an abundance of rubber domestically meant that vehicles, whether military surplus or newly produced civilian models, could be outfitted with durable tires at a scale never before imagined. Firestone, Goodyear, and other tire manufacturers not only supplied the booming U.S. car market but also began to export their products to markets around the world, solidifying their dominance. The success of synthetic rubber, however, had broader implications that extended far beyond the automobile industry. It opened doors to new forms of industrial material science, influencing sectors as diverse as construction, healthcare, and consumer goods. Rubber's versatility made it essential in creating products that had once been unimaginable or impossible. Medical equipment like blood bags, surgical gloves, and hoses all benefited from the advances in rubber technology. Consumer products, from footwear to waterproof clothing, were now made with higher quality, synthetic materials that could withstand wear and tear more effectively. Rubber's role in daily life expanded, and the resilience of synthetic rubber allowed industries to adapt to a rapidly changing world. Yet, despite these advancements, the U.S. was also reminded that the post-war world would not be free from challenges. The competition for rubber and other raw materials began to intensify. Other nations, particularly in Southeast Asia, re-established their natural rubber industries, and the market once again became saturated with cheap natural rubber imports. This posed a new dilemma for American producers. Could synthetic rubber remain competitive in a market when natural rubber was once again readily available? The answer came in the form of innovation. In the decades following the war, American tire companies and chemical manufacturers continued to refine the synthetic rubber process, making it more cost-effective and efficient. The long-term impact of Firestone's wartime contributions to synthetic rubber was not only in the materials produced during the war but in the foundational knowledge and infrastructure it helped create. By the 1950s, the synthetic rubber industry had evolved into a thriving commercial enterprise that could coexist with natural rubber, producing materials that were both cheaper and more versatile. The strategic importance of synthetic rubber during World War II also highlighted the importance of self-sufficiency in times of crisis. The U.S. would never again face a shortage of rubber to the same extent. It had learned the valuable lesson that relying on foreign supply chains for critical war materials, whether oil, rubber, or steel, was a dangerous vulnerability. This realization would guide U.S. policy in the Cold War years, as the country invested heavily in maintaining not only military supremacy but economic independence. For Firestone, the aftermath of its contribution to the war effort cemented its legacy as one of America's great industrial success stories. It had risen to the challenge of a national crisis and, in doing so, helped secure the Allied victory. But beyond the wartime contribution, Firestone's success in synthetic rubber was emblematic of the broader American spirit of innovation and resilience. The company's leadership and workers had not only responded to a dire need, they had transformed that need into an opportunity that benefited the world. Globally, the ripple effects of the synthetic rubber revolution were just beginning. Other countries, particularly in Europe and Japan, adopted similar technologies, forever changing the landscape of manufacturing and materials science. What had been a desperate wartime innovation blossomed into an enduring legacy that would shape industries and economies for decades to come. The development of synthetic rubber in 1942 stands as a testament to human ingenuity in the face of seemingly insurmountable challenges. What began as a race against time to ensure the mobility of military forces evolved into an industrial revolution that transcended wartime necessity. Firestone's innovation not only filled a crucial gap in wartime production, but it also reshaped the global economy, leaving a lasting legacy on both the rubber industry and the world's approach to manufacturing. This event underscores a broader lesson for history. In times of crisis, adversity can breed unprecedented innovation. The men and women at Firestone, from engineers to factory workers, embodied this spirit, turning a national vulnerability into a victory that changed the course of the war and the future of industrial production. Their success in creating synthetic rubber did more than supply the war effort. It proved that the U.S. could adapt and overcome its resource limitations through innovation and collaboration. It demonstrated the power of industry when united by a single purpose, and it revealed how a nation, faced with an existential crisis, could rise to the occasion and shape its own destiny. In the decades that followed, the advances made in rubber technology paved the way for improvements in countless industries, from automotive manufacturing to healthcare, leaving an indelible mark on the modern world. The synthetic rubber program, with its dramatic shift from scarcity to surplus, was a cornerstone of America's economic and military resurgence post-war. In a broader sense, the creation of synthetic rubber reminds us of the profound impact that war-driven innovation can have on everyday life. In the span of a few short years, Firestone's challenge became a solution not only for a world at war but for generations to come. The quest for survival in 1942 evolved into a legacy of progress, one that echoed far beyond the confines of rubber tires and military vehicles. Ultimately, the story of synthetic rubber is not just about tires on tanks or planes. It's about the unyielding determination of individuals, companies, and nations that refuse to be defeated by circumstance. It's about the quiet victories that, over time, reshape the world. Firestone's triumph stands as a reminder that even in the darkest times, human creativity, backed by unity and resolve, can turn a crisis into an opportunity. A lesson as relevant today as it was in the crucible of World War II.